Alright guys, so what we're going to work on today is 8.5 and 9.4. So it's more simplifying and operations with radicals. Alright, so kind of here's an outline of it. So what you want to do is you want to open up your textbook to page 523. This is a really great place to study for your chapter 8 test. These are guidelines for simplifying radicals. It goes through 8.1 all the way to 8.4. Just a good page summation. So please check that out. Now, now we're going to multiply radical expressions, use conjugates to rationalize denominators, and use conjugates to rationalize complex numbers. So this is where it's going to be this section 9.4. So when we're multiplying radical expressions, we're first going to use the distributive property. Okay, you saw this in 94 if you had like 2 times x plus 4. When you had a number multiplied by a binomial, so one term by a binomial, what you would have to do is you have to distribute that 2. So you'd go 2 times x plus 2 times 4, which would clean up to be 2x plus 8. Alright, so that's distributive property. Now what we're going to do next is the FOIL method. Okay, and with the FOIL method, that's first, outer, inner, last. Okay, so if we have x plus 3 times x minus 5. So if we have a binomial times a binomial, we take the first, so that would be x times x. The outers plus x times negative 5. Then the inners plus 3 times x, and then the last, plus 3 times negative 5. Then we clean up from there. So x times x is going to be x squared. Positive times negative is negative, so negative 5x, plus 3x minus 15, and the last thing we do is we combine our like terms. So we have x squared minus 2x minus 15 as our final answer. Alright, the next thing that we're going to do is we're going to use conjugates to rationalize the denominator. And all a conjugate is where you see opposite signs, which I'll show you what I mean as we get working with them today. Alright, so first thing we're going to do is we're going to multiply radical expressions by the distributive property. So for the first one, I got the square root of 3 times the square root of 49 minus the square root of 20. So the first thing that we're going to do is we're going to distribute the square root of 3. I would show this step if I were you. So we get the square root of 3 times the square root of 45 plus the square root of 3 times negative square root 20. The big mistake that I see is people don't carry their signs and then they end up getting the problem wrong. So square root of 3 times square root of 45 is the square root of 135. Positive times a negative is a negative. 3 times 20 is the square root of 60. Now what we have to look to do is to try to simplify like we were doing before. We don't have like terms, so we need to find the factors of 135, and we need to find the factors of 60. So for 135, that would be 1 and 135, 3 and 45, and then 5 and 27, and 9 and 15. We gotta look for a perfect square. My largest perfect square is 9, so I got the square root of 9 times 15. I can pull out square root of 9 is going to be 3, square root 15, and now I just need to deal with the 60. So factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, and 5 and 12, and then the last one is 6 and 10. So I'm looking for my perfect square, which would be 4. So this would be the square root of 4 times 15. Square root of 4 is going to be 2, square root 15. Now again, my radicals have to be exactly the same, which they are now, so that's the square root of 15, and then 3 minus 2 would be 1. So you can leave it like this, or you could put a 1 right here, if you'd like. And there's your answer. Alright, so what I want you to do is I want you to pause it, I want you to try to do B. Okay, B says the square root of 2 times the square root of 8 plus the square root of 20, so I'm going to distribute that square root of 2. So I get the square root of 2 times the square root of 8 plus the square root of 2 times the square root of 20. 8 times 2 is going to be 16, so I get the square root of 16 plus the square root of 2 times 20 is going to be 40. Alright, we see that 16 is a perfect square, so that's going to be 4. Now we find our factors of 40, 1 and 40, 2 and 20, 4 and 10, and 5 and 8. My perfect square is going to be the 4, so I'm going to go plus the square root of 4 times 10. The square root of 4 is going to be 2 square root of 10. Next thing I look at, are my radicals the same? No, because this one doesn't even have a radical. So this is as far as I could take it. The common mistake that I see here is that people will try to go 4 plus 2, but you can't do that because your radicals aren't the same. They must be the same in order to combine like terms. Okay, so this is the distributive property. Hopefully you feel pretty comfortable with it. Now what we're looking at is we're looking at the FOIL method. And remember, FOIL is first, outer, inner, last. So let me read the problem first. So I got 2 square root 3 plus the square root of 7 times square root of 3 minus 3 square root 7. Alright, so whenever I have a binomial times a binomial, I know I'm going to use the FOIL method. Alright, so to help me to write it out, I usually write FOIL out, and then I cover up in my first binomial the second term that I see. So then it just kind of turns into the distributive property just like we did in the last two problems. So let me show you what I mean. So for first, I would do 2 square root 3 times my first term, which would be the square root of 3. Then I got to do my outer, so I'd go 2 square root of 3 times negative 3 square root 7. Okay? So I've exhausted the 2 square root of 3, so now I'm going to cover that up, and now I'm going to deal with my inner. So this would be the square root of 7 times the square root of 3 plus the square root of 7 times negative 3 square root of 7. So it helps me with my signs, and it helps me to make sure that I write down all my terms. Okay, so now let's clean this up. So I've got 2, and then square root of 3 times square root of 3 is 9. So I got 2 square root of 9. Positive times a negative is a negative. 2 times 3 is going to be 6. 3 times 7 is going to be square root 21. Positive times a positive is a positive. Square root of 7 times square root of 3 is going to be the square root of 21. Alright, positive times a negative is a negative. 1 times 3 is going to be 3. Square root 7 times 7 is going to be, or square root of 7 times square root of 7 is going to be the square root of 49. Alright, now we definitely have to clean this up just a bit. So square root of 9 is going to be 3. So we got 2 times 3 going on right here. We can combine some like terms because we have the same radical. So we got the square root of 21, but negative 6 plus 1 is going to be negative 5. And then we got minus 3 square root of 49 is going to be 7. So 3 times 7. Okay, so now let's clean this up a little bit more. 2 times 3 is going to be 6. So we got 6 minus 5 square root 21 minus 3 times 7 is going to be 21. Okay. So then we just got to finish it up, combine our like terms. We got the 6 minus 21, which will be negative 15 minus 5 square root 21. So this process is definitely tedious, but if you follow it step by step, you should be okay. Okay, let's try another one. So we got square root of 2 plus 5 square root of 3 times square root of 3 minus 2 square root of 2. Alright, first thing I see is I see 2 binomials, so I know I'm going to use the FOIL method. Alright, so I'm going to take my first binomial and I'm going to cover up the second term. So I'm going to do the square root of 2 times the square root of 3 for my first, plus the square root of 2 times negative 2 square root of 2 for my outer. Now I've exhausted the square root of 2, so I'm going to cover that up, and I'm going to go 5 square root of 3 times the square root of 3 plus 5 square root of 3 times negative 2 square root 2. Alright, now let's clean this up. Square root of 2 times square root of 3 is going to be the square root of 6. Positive times a negative is a negative. 1 times 2 is just going to be 2. Square root of 2 times square root of 2 is going to be square root of 4. Then we've got positive times a positive, so it's going to be positive. 5 times 1 is 5. 3 times, or square root of 3 times square root of 3 is going to be the square root of 9. Positive times a negative is a negative. 5 times 2 is going to be 10. Square root of 3 times square root of 2 is going to be the square root of 6. And now let's clean this up. Square root of 6 can't simplify at all, so I'm just going to bring that down. Square root of 6. Then we've got minus 2. Square root of 4 is a perfect square, so that's going to be 2. Plus 5. 9 is a perfect square, so that's going to be times 3. Minus 10 square root 6. Alright, so I see that I have two radicals that are exactly the same, so I can combine those two together. And 1 minus 10 is going to be negative 11. I'm so sorry, that's not right. I'm sorry. 1 minus 10 is going to be negative 9, so I've got negative 9 square root of 6. And then let's continue to clean this up. So positive times a negative is going to be a negative. 2 times 2 is 4. Plus 5 times 3 is going to be 15. Okay, so we got negative 9 square root 6. Negative 4 plus 15 is going to be plus 11. Now, I don't care which order it is when you're just dealing with radicals. So either way would completely be fine with me. Okay? Let's look at the next one. So this one says it's a binomial squared, so we got the square root of 5 minus 3 parentheses squared. So all this means is you have the square root of 5 minus 3 times the square root of 5 minus 3. So what I want you to do is I want you to pause it and I want you to work through it. Okay, so when I see two binomials, the first thing I'm going to do is I'm going to write f plus o plus I plus L. I'm going to cover up my second term, and I'm going to go the square root of 5 times the square root of 5 for my first, plus the square root of 5 times negative 3 as my outer, plus negative 3 times square root of 5, plus negative 3 times negative 3. Alright, now I'm going to clean this up. Square root of 5 times square root of 5 is the square root of 25. Positive times a negative is a negative. So this would be negative 3 square root 5. Negative times a positive is a negative. So this would be negative 3 square root of 5. Negative times a negative is a positive. 3 times 3 would give me 9. Okay, square root of 25 is going to be 5. I can combine my like terms. So I got the square root of 5. Negative 3 minus 3 is going to be negative 6 plus 9. Combine my like terms, so 5 plus 9 is going to be 14. And minus 6 square root 5. Okay. So now what I want you to do is I want you to take this one and I want you to do it completely all by yourself. Okay, so first thing we're going to do is going to write it twice. So we got 4 square root 2 plus 5 times 4 square root 2 plus 5. Then I see two binomials, so I can go f plus o plus I plus L. Cover up my second term, so I've got 4 square root of 2 times 4 square root of 2 plus 4 square root of 2 times 5. Cover up the 4 square root of 2, so I got 5 times 4 square root 2 plus 5 times 5. Now let's clean it up. 4 times 4 is 16. Square root of 2 times square root of 2 is 4. 4 times 5 is going to be 20. Square root of 2. 5 times 4 is going to be 20 square root of 2. And 5 times 5 is going to be 25. Let's clean it up a little bit more. So we got 16. Square root of 4 is going to be 2. So 16 times 2. We're going to combine our like terms. So we get the square root of 2, and then 20 plus 20 is going to be plus 40. Plus 25. Alright, 16 times 2 is going to be 32. Plus 40 square root of 2 plus 25. And then 32 plus 25 is going to be 57 plus 40 square root 2. And that will be my final answer. So this is the FOIL method. Hopefully it helps. Alright, so next term that we have is this thing called a conjugate. When you have two radical-filled binomials that look exactly the same except for their sign, they are conjugates of each other. So what happens is the disappearance of the radical will happen every single time. Let me show you what I mean. So if I've got the square root of y minus 4 times the square root of y plus 4. So my terms are exactly the same. The only thing that's different is my signs. So typically if I saw two binomials, I'm going to use that FOIL method. Okay, so I do the square root of y times the square root of y plus the square root of y times 4 plus negative 4 times square root of y plus negative 4 times 4. When I clean this up, this would be the square root of y squared plus 4 square root y minus 4 square root y minus 16. Alright, so square root of y is going to just be, or the square root of y squared is just going to be y. My radicals are exactly the same, but 4 minus 4 gives me 0. So what happens is this disappears, and that will happen every single time when you have conjugates. So then all I'm left with is minus 16. And this will happen every single time. Okay? So, all I want you to do first is I want you to find what the conjugate is. So all we're trying to do is change the sign. So if I got 2 plus 5 square root of 3, to be able to find that conjugate, it's going to be 2 minus 5 square root 3. Okay? If I've got square root of 10 minus the square root of 2, my terms stay exactly the same, so I go to the square root of 10. But instead of minus, it's going to be plus the square root of 2. Those are going to be conjugates of each other. Now the whole reason that we're doing this is we're going from, if we had, 5 over the square root of 3. Okay, remember how we can't have a square root in the denominator? Well, it's going to be the same for the next slide too. So remember what we'd have to do is the square root of 3 over the square root of 3, which would be 5 square root of 3 over the square root of 9. So 5 square root of 3 over 3 would be my final answer. Okay, so the difference between this and rationalizing a binomial denominator is instead of just having a radical, what you're having is you're having some type of addition or subtraction. So in order to clean that up, what you have to do is you have to multiply by the conjugate. So if I have 3 over 4 plus square root of 3, first thing I have to do is I have to multiply my bottom and my top by the conjugate. So it needs to be 4 minus the square root of 3. And what I do to the bottom, I have to do to the top. Okay, so first thing you want to do is identify your conjugate. The next thing that you have to do is you have to FOIL the top, distribute the top and FOIL the bottom. So we would go 3 times 4, which would be 12, minus 3 square root 3. And then for the bottom, we would have to FOIL. So 4 times 4 plus 4 times negative square root 3 plus the square root of 3 times 4 plus the square root of 3 times negative square root 3. Give you a second to copy that down. So now if I clean this up, I've got 12 minus 3 square root of 3. 4 times 4 is 16. Minus 4 square root of 3 plus 4 square root of 3 minus the square root of 9. So when I clean that up, that would be 12 minus 3 square root 3 over 16. And you see right here that this cancels out. Minus square root of 9 is going to be 3. So we get 12 minus 3 square root of 3 over 16 minus 3, which would be 13. The last thing that you want to check for is you want to check your coefficients to see if you can do any type of triangle canceling, but you cannot for that one. So what I mean with triangle canceling is like this. If you had 4 minus 6 square root 2 over 4. So when you look at your coefficients in the triangle, you see that you can do some canceling because they're all even digits. So what can go into 4, 4, and 6? Well, that would be 2. So 4 divided by 2 would leave me with 2. 6 divided by 2 would leave me with 3. And then 4 divided by 2 would leave me with 2. So my final answer would be 2 minus 3 square root 2 over 2. You don't include the radical, it's just the coefficients in front. And it makes the shape of a triangle. That's why it's called triangle canceling. Alright, let's try another one. So we got square root of 5 plus 3 over 2 minus the square root of 5. First thing I notice is I can't have a radical in the denominator. So what I have to do is I have to multiply my bottom and my top by the conjugate. So the terms stay exactly the same. The only thing that changes is the sign. Alright, and unfortunately for this one, we have to FOIL both the top and the bottom. So pause it and try to see if you can FOIL and simplify. Alright, so I'm going to take the square root of 5 times 2 plus the square root of 5 times the square root of 5 plus 3 times 2 plus 3 times the square root of 5 all over 2 times 2 plus 2 times the square root of 5 minus the square root of 5 times 2 minus the square root of 5 times the square root of 5. Alright, 2 times, so this would be 2 square root of 5 plus the square root of 25 plus 6 plus 3 square root of 5. Which I'm going to finish cleaning that one up too. So this would be 2 square root of 5 plus 5 plus 6 plus 3 square root of 5. So when I clean that up, I can combine my like terms. So 2 plus 3 is going to be 6 square root of 5 plus 11. I messed up. Oh, sorry. 2 plus 3 is not 6, it's 5. So 5 square root of 5 plus 11. Now let's look at the bottom. 2 times 2 is going to be 4 plus 2 square root of 5 minus 2 square root of 5 minus square root of 25. So those cancel out and I'm left with 4 minus 5. 4 minus 5 is negative 1. So the last thing I've got to do is I can't leave a negative 1 in the denominator, so I've got to distribute it through. So this would be negative 5 square root of 5 minus 11. Hopefully that's what you got. If you got to here, you're doing good. You just got to make sure and apply that to the top and the bottom. So anytime you have a negative 1, you got to apply it to the top and the bottom to simplify. Alright, got one last one like this. I want you to try it by yourself. So pause the video and do it by yourself, please. Alright, so we got 3 over 2 plus the square root of x. So first thing I want to do is multiply by the conjugate. So it would be 2 minus the square root of x over 2 minus the square root of x. The top we're going to have to distribute. The bottom we're going to have to FOIL. So we'd go 3 times 2 plus 3 times negative square root x, which would be 6 minus 3 square root x. Then we'd go 2 times 2 plus 2 times negative square root x plus the square root of x times 2 plus the square root of x times negative square root of x. Man, I didn't leave enough room, sorry. I'm going to cross that out. We'll go below. So that'd be 6 minus 3 square root x. 2 times 2 is 4, minus 2 square root of x plus 2 square root of x minus the square root of x squared. So that would be 6 minus 3 square root of x over these cancel out, and I'm left with 4 minus x. Now, because there's a minus x in the denominator, there's nothing else that I can do to try to cancel anything out. So there's my answer. Hopefully you did okay on that one. Alright, now we have complex numbers. So a complex number is a number in the form a plus bi, where a and b are real numbers. So if a equals 0 and, I'm sorry, this should be there, that's how it should be. So if a equals 0 and b does not equal 0, then bi is a pure imaginary number. Okay, so a complex number always goes in a plus bi form. So an example of this could be like 4 plus 2i. Okay, so you'll always see that I. The important part that you need to know about complex numbers is this right here. When you have a complex, or when you have an I raised to an exponent. So if you have I to the first power, you're just going to get I, and it always follows a pattern. I to the second power, it's going to be negative 1. I to the third power is going to be negative I, and then I to the fourth power is going to be a positive 1. This is the pattern that it always follows. So I to the fifth is going to be just I to the sixth is going to be negative 1. If I had I to the seventh, that would be negative I, and if I had I to the eighth, that would be a positive 1. And if I had I to the ninth, then it's going to start that cycle all over again. So it's going to be negative I. Okay, so remember, products of conjugates erases the radical. What it does for complex numbers is it erases the imaginary number. Okay, so if I have a plus bi times a minus bi, remember they're conjugates of each other because the terms are in the exact same spot. You just have opposite signs. So when you have a binomial, you have to FOIL f plus o plus I plus L. So we'd go a times a plus a times negative bi plus bi times a plus bi times negative bi. Alright, so if I clean this up, this would be a squared minus abi, try to do an alphabetical, plus abi, okay, and then minus bi squared. Okay, because I times I is going to be I squared. Alright, so here are my terms. So this is a squared. These two cancel out with each other because negative ab plus ab cancel out with each other, and then we go minus b times I squared is going to be negative 1, so times negative 1. So we get a squared plus b squared. I'm sorry, there should be a squared right here because b times b is b squared. Okay, so this is the proof that it goes behind, but the things that you need to know is you need to know whenever you see I squared, you need to replace that with a negative 1 and clean it up. So let's make it real. So if I have 3 minus I, excuse me, over 2 plus 3i, first thing I see is I see that I have an imaginary number in the denominator, and that's not allowed. So I have to multiply by the conjugate. So I'm going to go 2 minus 3i on the bottom, and then 2 minus 3i on the top. Again, unfortunately, we have to FOIL because we have two binomials. So let's go ahead and knock this out. So we'd go 3 times 2 plus 3 times negative 3i minus I times 2 minus I times negative 3i. And I'm just going to go ahead and clean up the top first, and then I'll get to the bottom. So 3 times 2 is going to be 6 minus 9i minus 2i plus 3i squared. Okay, so again I'm going to clean up just the top, so I'm going to be left with 6. I can combine my like terms. So that would be 6 minus 11i plus 3. And then instead of having I squared, we're going to replace that with a negative 1. So 3 times negative 1. So that would be 6 minus 11i minus 3, which would finally clean up for us. 6 minus 3 is going to be 3 minus 11i for my numerator. Okay, and it's important that you keep it in the a plus bi form. Alright, so now let's clean up the denominator. So we'd go 2 times 2 plus 2 times negative 3i plus 3i times 2 plus 3i times negative 3i. So 2 times 2 would be 4. 2 positive times a negative is a negative, so negative 6i plus 6i minus 9, so 3 times 3 is 9, I squared. Alright, when we combine like terms, what we see is negative 6i plus 6i cancels out, so I'm left with 4 minus 9, and then instead of I squared, we're going to replace that with a negative 1. So that would be 4 plus 9, which would be 13. Last thing we do is check to see if we can triangle cancel. We can't. That's our answer. Okay. Oh, one thing with this, the back of your textbook will break it up like this. I do not care. This completely works for me. So if you can keep it and it's simplified as much as possible, then that's fine by me. If you want to break it up and put in the a plus bi form, you can, but you don't have to. Alright, pause the video. I want you to do b for me. Okay, so we have 3 plus 4i over 1 minus I. First thing I want to do is I want to multiply by the conjugate, so I got 1 plus I. What I do to the bottom, I have to do to the top. So I've got to FOIL the top, so I go 3 times 1 plus 3 times I plus 4i times 1 plus 4i times I. And I'm going to clean that up like we did in the last one. 3 times 1 is 3 plus 3i plus 4i plus 4i squared, which would be combining like terms. 3 plus 7i plus 4 times negative 1, because I have to replace I squared with a negative 1. So that would be 3 plus 7i minus 4. Combine like terms again, and that would be negative 1 plus 7i. So that's my numerator. Now let's focus on the denominator. 1 times 1 plus 1 times I minus I times 1 minus I times positive I. So that would be 1 plus 1i minus 1i minus I squared. Those cancel out, leaving me with 1 minus negative 1. So that would be 1 plus 1, which would leave me with 2. I'll look to see if I can triangle cancel. I can't, so I leave it right there like that. Alright guys, so you've got 2 homework assignments with this one. You got 8.5 and you have 9.4. 9.4 is only 2 problems though, but please make sure that you get this down because you will see a question like this on your Chapter 8 test. Alright guys, get to work. Make sure you show all work. If you have any questions, make sure you bring them to class so that we can discuss through them. Alright, thank you.